Question 2. Figure 1 shows an isolated sphere that has been given a positive charge. There we can see Figure 1 with a positively charged sphere. Part A. Add 4 field lines to Figure 1 to show the electrical field pattern produced by the sphere for 2 marks. So there's 2 parts to this question. We need to orientate the field lines correctly and also put the correct direction on them. Now, because it's positively charged, the field lines need to be pointing away from the sphere. And they each need to be at 90 degrees, like so. So that would score 2 marks available for this question, because we've got the correct direction and the correct orientation. Now, what we do need to be careful about here, though, is making sure we've got the correct number of field lines. It would be easy to miss that fact that it does specifically say 4, so make sure you're adding 4 field lines on. Part B. There are charged ions in the air around the sphere in Figure 1. A positive ion is 50 centimetres from the sphere's surface, and negative ion is 80 centimetres from the sphere's surface. The charges on the ions are the same size. Which 2 statements are correct? Tick 2 boxes. Okay, so we're looking for the 2 statements that are essentially the most correct, because there are 2 of them, aren't there? So let's see which ones it's going to be. The positive ion is attracted to the sphere. Well, we can be fairly certain that's not correct, or in fact we can guarantee it's not correct, because a positive ion will not be attracted to a positively charged sphere. The force on the positive ion is larger than the force on the negative ion. Well, let's refer back to the question. We can see that the positive ion is actually closer than the negative ion is. So yeah, that certainly seems like it could be correct. Third one, the negative ion is attracted to the sphere. Well, that will also be correct because the sphere is positively charged. Now, it would be tempting just to tick those 2 boxes in the middle, but we should read the 4th point just to make sure we can be secure in our answer. The force on the positive ion is smaller than the force on the negative ion. Well, yes, we know that's definitely wrong for the reason we just discussed, because the positive ion is closer. So we put a tick there and a tick there, and that scores the 2 marks available for this question.